Welcome to Sensing the Signal. I'm Terry Patar from Atreides. We're exploring the overlap between data, technology and intelligence in our increasingly volatile and complex world, what this means for national security and how deeper insight can help organisations make better decisions. I've spent the past 20 years helping organisations improve their intelligence capabilities. I'm fascinated by how we understand the world around us. Now I get to talk to some of the leading voices who I've learned from myself.
This time on Sensing the Signal, we've come out on the road again and we are visiting Purple Sector, and we're talking to Mark Mathieson, founder and CEO of the company. So you might wonder what the noise is. This episode is going to be all about what defence can learn from Formula One. Hence, we've just been listening to some engine noise, and Mark, maybe you can start off by talking us through what we've just heard and what it tells us about some of the work you're involved in, and we can delve into some of your background after that. So welcome to the show.
Thank you, Terry. It's great to be here, and thank you for coming to join us on site today. So to answer your question, the engine on the dyno was a performance V8 engine, not one of our racing engines. We have a sister company that make racing engines, and that's actually my background. So I started out on my engineering career on this very site about the age of 10, I think.
So there's a lot of history here.
Oh yeah, there's a lot of history, yeah. So this site actually is the coaching point halfway between London and Portsmouth. They used to change the horses, repair the coaches here. The inn over the road is now 2 houses. Then it turned into a garage, and my father acquired the site in the early 80s. And I started working here about the age of 10, taking racing engines apart.
Wow. And talk us through what we've just heard, though. So we heard there two times of the engine being run. It will have sounded to people very similar, but there was a difference.
Exactly, yeah. So we couldn't hear the difference ourselves, but there was actually a difference in the setup of the engine when it went through those test curves. And we run a system, we're training that system to discern non-normal activity. And so it picked up the difference between those two curves, which was a slight change in throttle angle, intake throttle, which again, we wouldn't hear ourselves, but it discerned the difference.
So Purple Sector, you're building high-performance sensors because you come from a high-performance industry and engineering background. But talk us through a little bit more about what the company does and what you offer. And so just so people can get a sense of it. And also, for anyone who's listening who is into Formula One, the name will be redolent of Formula One, but maybe you can explain it for anyone who's not familiar.
Okay, I'll start with the last point,
sure, yeah.
And then go back to the former.
Yeah.
So Purple Sector comes from the racing link. So a lap of a circuit is broken down into sectors. And if you go purple in a sector, you're the fastest car out there. And if you go purple all the way through the sectors, you are going to have the fastest lap time. So that's the link to the name.
It's all about speed, which,
exactly. And there's a lot more. It's not just the driver having a great moment. There's a lot that goes on behind that achievement, and that's the real point behind the company. So what do we actually do? We take a lot of that Formula One learning, the technology, the tools, techniques, and culture out to industrial applications, and we call that industrial racecraft.
It's a really interesting concept. I love the name of it. Can you explain a bit more about what it means and what it means in practice as you try and take that out of Formula One and into other sectors? And I suppose, from the perspective of a lot of people, they'll see Formula One and they'll think it's obviously really top level, high performance sport that requires a lot of engineering, etc. But yeah, maybe you can just give us a bit more of a flavour for the things you touched on there, the sort of culture and everything else, and what that means in other places outside of the sport itself.
Yeah, so I guess in many respects it's challenging the paradigms that exist in industry. The point of reference that we have is all the way back to COVID under the Ventilator challenge. And I was asked by the Cabinet Office via some links into that area through an Auto Council responsibility, whether we could mobilise Formula One to help with that challenge. So we duly did, mobilised Formula One in the UK, and worked alongside some major industry players like Siemens, Airbus, Ford, Rolls-Royce. So that enabled the scale-up capability, but the differentiator was the way we approached it. And so that was the essence of industrial racecraft, and that came from the Formula One background. So the headline achievement was 23 years worth of normal production of a full ITU ventilator in just 12 weeks. And
Wow.
we re-engineered over 65% of the ventilator because it was never designed to be made in that sort of volume. And I think the peak production in a week before COVID was maybe 15 units. We peaked at 402 in a day. And that was a lot to do with the will-do attitude. There's no option here. It's got to be done. But also the methodologies of concurrent engineering, a decision-led approach. So it's not a waterfall of tasks. It's very much about what decision do we need to make next, and what information do we need to enable us to make that decision well. And you focus on getting that information, and that enables you to move a lot of activity in parallel and just focus on the important stuff.
And so that came probably not that long after you'd set up Purple Sector, is that fair?
Yeah, it's about right. Yeah, so we had started, well, probably only about 6 months before
Right, wow.
we bumped into COVID.
Yeah.
So we took that challenge on.
Where were you prior to that? So give us a sense of your background in Formula One, etc.
Yeah, so I learnt my basics in engineering here, as I said.
Yeah.
I probably went racing age of 13 as a mechanic.
Nice.
But then I went off and did a degree at Bath University, mechanical engineering. Went into mainstream consulting with Ricardo Consulting Engineers. Great foundation for me, actually. A lot of experience very quickly. Did about 4 years there, but always had the desire to jump into Formula One. So I launched myself into a company called Ilmore Engineering, formed by Paul Morgan, Mario Ilian, backed by Roger Penske.
These are all famous names. For those who aren't familiar with them from the world
so
of
hence
racing.
the name
Yep.
Ilmore,
Yep.
Ilian and Morgan. And so, it was a relatively small company that got backed by Mercedes really just as I joined. And so we grew very quickly, and it was a great environment. I mean, I got very, very lucky with the opportunity, and I ended up running the Formula One powertrain program for Mercedes. I was there for about 10 years. Mercedes eventually bought the company, and I worked with Ola Kalanius, who is now chair of the board at Mercedes, or Daimler. He was my immediate boss, and we worked together to build a foundation for the future of the Formula One activity of Mercedes, which is all in this country.
And that was during a really successful period.
Yes,
Yeah,
yes. And McLaren were the works team for us at the time in Formula One, and then obviously Mercedes bought their own team, and it grew from there.
That's excellent. And then coming into Purple Sector, you had that intention, I suppose, of taking what you'd learned and bringing it out into other sectors. But then COVID, I mean, how much did that really drive your, I suppose, belief and confidence that, yes, actually, there is a need for this, and there is an instant impact we can have in other sectors?
Yeah, so that was the game changer. Before I ended up running Purple Sector, I did a quick detour into McLaren. Spent about probably 10, 15 years there on the automotive side, setting up the car company, and then into the applied technologies part of the group, which the group divested from that, and that gave us the opportunity to form Purple Sector. And that was very much the application of mostly Formula One derived technology into industrial applications. And so that was my insight into it. But the COVID opportunity was really the validation that it was beyond the influence of the McLaren brand. There was really something here that was common across a lot of industrial applications.
What really drives that? And where does that come from, that sort of motivation to do that?
I guess it's a sense of sovereign pride. I know we can do it, so why can't we do it? I used to walk home. I mentioned the company I joined, Ilmore Engineering. I used to walk home, and my normal day was probably about 8:45 in the morning to 1 or 2 o'clock the following morning.
Wow.
My nickname was Midnight Mathieson. If there was a problem with an engine on the dial, just call Mark. It's 1 o'clock in the morning. Yeah, but he'll still be here. And that was the intensity of it. But I used to walk home buoyed by the fact that I really remember thinking that we could take anything on here. We could just do anything. And if there was a crisis, we'd be right in the middle of it. And we had the chance to demonstrate that when we entered COVID. And that was where we were. It's not about the race anymore, although it was a race, because what was being fed back to us was that the frontline clinicians, because we were so desperately short of ventilators, they had to make a hard decision. We've got a chance for 3 people to survive, but I'm faced with 10 people. So who are the 3 going to be? And there's nothing like that as a focus, that it's the will-do attitude. We have to get this done. And so there was a passion that came through, and we demonstrated that we could actually do this. And once you start to get this rolling and go, wow, we can actually do this. And everyone was behind the challenge. And so that, to me, was a moment of realization that, yes, that's an extreme case. Throttle back a little bit and go, well, we could work at that standard all of the time. And we do lead the world in a lot of innovation, and certainly in the Formula One engineering stakes, a majority of the teams are here, and that's for a good reason. So let's exploit it as a nation. Let's use that.
And can you give us an example from some of the work you've done in defence, and give us a sort of practical illustration of what that means?
Well, a great story, actually. Obviously, drones are very popular in conversation at the moment in defence circles. There was a little drone company in the UK that there's a great story behind it, actually. So it's a prof at a university, had the knowledge, the aero knowledge. He rallied together a bunch of postgrads, had an external investor, someone with a bit of vision and some funding to put behind it. A long story short, they built a flyable aircraft, autonomously controlled, in the corner of an old lab at the university. It wasn't ever intended for MOD applications, so it has some very good applications in aid delivery, much more accurate delivery of aid.
So you mean in terms of dropping packages?
Yeah, correct. Yeah, so it's a fixed high wing aircraft, a twin engine with a payload of about 150 kilos.
That's really important, because in disaster relief scenarios, you need stuff to land in very precise
places.
Otherwise, it gets lost or damaged or whatever.
Correct. Yeah. So and that was the thinking, and that's still part of the business case. But they entered a few MOD competitions and were very successful. Got noted, and all of a sudden there was a demand signal for 10 aircraft. And crikey, how do we make 10 aircraft? So we got involved. We re-engineered quite a few aspects of it, because no surprise, it hadn't been designed for that product application by experienced people at the time. And again, a lot of credit for them to get the thing built and in the air as they did. But we went through that and then resourced the entire supply chain to get the right level of quality and pace. And we collapsed the original build time from 24 months down to about 3 weeks. And again, the first prototype would take longer anyway, but we got it down to 3 weeks per aircraft and got all 10 out of the door and delivered to the MOD. So that's a really good example of the art of the possible. A relatively small project, but that was a breakthrough moment.
Yeah, excellent. I suppose, one of the reasons we're here talking is, a lot of the time on this podcast, we focus on bringing new technology, innovation into defence and other sort of related sectors. But you wrote a really interesting article in UK Defence Journal about this, and so I guess the question is, from your perspective, why the defence sector, and why do you think actually some of these experiences and the industrial racecraft methodology you can bring into defence? Why sort of that specifically, that area, but also what would be the benefit, I suppose, in terms of what you see immediately as the need that you can deliver on?
So, in very simple terms, we're seeking to do more for less and do it faster. And if we ever needed...
But I mean, that sounds really simple in principle. How does it work in practice? Because, what are the sort of systems you need to build to enable that to happen?
Yes, we've talked a little bit about the decision-led approach and prioritising what you do and when you do it, but there's some other principles within there. We say a decision should be made at the point of greatest knowledge. So that's typically the expert with the best data. And so there's two things there. Okay, there's the expert, and you are in recognising that and empowering that person to make a decision, but you're also providing that person with the right information at the right time. And quite often, particularly in the modern world, we love data, but you come back to, okay, what are you using the data for? And we start at that point and go, okay, so what are you trying to achieve? What's the performance you're trying to deliver? And the analogy to a Formula One application is lap time. So reducing lap time all the time. That doesn't translate directly to the target within a Formula One team across the whole organisation. It might be that in manufacturing or in operations, it's about how do I take this latest great idea through to a part that can be fitted to the car to exploit the advantage as quickly as possible. That's my contribution, and it's the pace through our system. So it translates into other terminology for different areas in an organisation, so it is contextualised. So we take that out and we get organisations to think about, so what are you trying to deliver here? Okay, now we understand that. What data most significantly affects that outcome? Okay, now we understand that. So are you measuring that? And quite often the answer is no, not sure, or we are, but I'm not sure how good a quality it is. Okay, let's start there and let's get the data measured. So that's where we've got into bespoke sensor deployment. So typically in a industrial application, you can't just stop a production line and just mess around with sensors. So we've developed a series of non-contact specialist sensors. That's a starting point to try and understand problems and feed data in. And then we start to work with the team, and that's key. It's not just because we come from Formula One we can solve every problem. It's a bit of different thinking from us and some tools and techniques married with the extensive domain knowledge that the client has. Those two elements come together to solve the problems that they're facing day to day, and they've probably been carrying those challenges for months or years in many cases, and we seek to solve those very quickly.
That all sounds amazing. Can you maybe touch a little bit on what those sensors are, and just give us a quick description of the sensors that are involved? That I believe you guys have uniquely produced and have that capability, and you can take that out to other areas.
Yeah, so we're looking at all of the, if you like, natural senses. So sight, sound, smell, they all apply themselves. So barn owl is our vision system. So we use that to observe for example, a manufacturing system, but it could translate equally to a defence application. It will learn normal behaviour very quickly and therefore discern non-normal. And something that is moving faster than the human eye can actually follow, you can then identify with that system. So we've had a good example on a large-scale pharmaceutical line where they were having a failure on an increasingly regular basis. And this system found something that they hadn't ever seen before, but it found it in the first deployment. And a significant saving. When you're pushing vials of drug through that are critical for the end user and very high value, and they're going through at about 600 per minute. If you have a failure and then the downtime is 6 or 7 hours, you can see if you solve that problem, there's a lot of upside. So that's one example, and there's sniffing. We had a chocolate manufacturer say, "Can you help us with the manufacturing process?" And the phrase "black art" was referred to, and we know as soon as that's said that there's an opportunity here, because there is always science below that. We developed a sniffing sensor. One of our guys did it on his kitchen table at home, got the first prototype up and running, deployed it on the Monday, and it gave immediate insight into the process. And so something that was typically taking 6 or 7 hours was compressed in some cases down to 30, 35 minutes because we suddenly understood the process.
Wow. Okay. That's incredible. One other thing I want to touch on briefly is if you give us a sense of, when we're talking about Formula One and we're talking about taking the lessons out, industrial racecraft, and And for those who maybe look at Formula One, they see the fun aspects and they see, the team that support the mechanics that support the race car, etc., and the drivers. What they probably won't see is the level of complexity involved, especially on the engineering side, but also on the people side. And there's thousands of people in a Formula One team who are responsible for different individual aspects, whether it's the engine or the chassis or whatever it might be, who are supporting that team, who are at the racetrack, getting the car around the circuit. But then there's also, I think you said, how many sensors typically on a Formula One car?
300 plus.
300 plus sensors generating
over a terabyte.
Over a terabyte of data per race.
Yeah.
So we're talking masses of sensors, we're talking masses of data, and through everything you've learned about how to handle that's really vital in what you're taking out to other sectors.
It is, yeah, and the principles there of measuring what you need to measure. So you've got to make a very good case to get a sensor on a car, right? Because you're taking up, you're spending weight and you're taking space. Yeah. So the principles of just what you need. That's part of it, but you describe what is actually, unbeknown to a lot of people, a very complex environment in Formula One, which is using quite a few people these days and a lot of tools and techniques around it. So the average Formula One team, the car side of it, if you like, will be probably north of 1,000 people. Mm-hmm. And then on the powertrain side, which is obviously complementing the car side, you need an engine and the other parts to go with it to make the car go. That's another 1,000 people or more. So it's a big undertaking. However, in the modern day of Formula One, there is a cost cap. Mm-hmm. So it's restricted to generate a more level playing field. To make it more competitive. And you've seen the advantage of that over recent years with McLaren as an independent team, not a works team, so not backed by a big manufacturer. They've been successful in winning the World Championship, and that's been largely down to that level playing field. But what that has meant for all of the teams is that they've got better at what they do. It's an interesting development. You've brought the budget down. And actually the teams have looked at that and said, well, it's a competitive opportunity, this. The more we can wring out from that fixed amount, the more advantage we get. So how do we get better at what we do, more effective and more efficient? So there's even more learning that's coming out from that environment now. So there's a lot of elements to Formula One that people don't necessarily appreciate, and they might assume that it's big budget and very small, very specialised teams. It's actually grown to be quite a large industry with a supply base around it as well. And the thing that we should be very proud of is that a lot of teams, a disproportionate number of Formula One teams, are based in the UK because actually we're very good at this.
That's where all the expertise is.
Yeah, the expertise there, but also the culture and the attitude, the will-do attitude, which is something that came to the fore in the Ventilator Challenge. It's not I could do or I should do. We will do. And it comes to the car will be on the grid for the start of the race.
Yeah. That's probably a great point at which I can bring in one of my colleagues. So Chris Toast, who's with us.
Hello.
Welcome, Chris, to the show. First time on the podcast.
But, it is, yep.
Yeah,
happy to be here.
Excellent. And I wanted to bring you in because you and I were actually having a discussion a few weeks back before we'd decided, confirmed this episode was happening, etc. But about exactly this topic, what can defence learn from Formula One? And maybe you can just, for people who haven't come across you before, give a little bit of your background and what your focus is, and then we can delve into some of your questions. Because I know when we talk about people and culture, that's really where you want to get into the details.
Yeah, for sure. So spent 10 years full-time in the military and not in the military anymore, but still very involved in supplying data and intelligence and other services to the military and other organisations that are involved in investigations, journalism, etc. What really strikes me about what you're talking about is the difference between an operational mindset, say when we're deployed, versus a peacetime mindset. And I spent a lot of time in the peacetime environment developing technical innovation, especially around open source intelligence and defence. And you can see that stark difference between when people are deployed, when we are behind a mission, when there is a wider existential threat. The military completely makes sense. Everything aligns behind that. We have that will-do attitude that you described. I think the challenge is, and maybe what we can learn from you, is how you've managed to do that in a peacetime environment when the bureaucracy and the lack of impetus to achieve mission success is more obvious. So I think that would be great to talk about. One of the other things you mentioned, the culture. So I think one of the things we've noticed, both Terry and I have both noticed this with our different engagements with defence, is everybody would expect, for example, the racers, the engineers, the pit teams, they're going to be aligned to mission success. They want to win the race. Everybody understands that. How do you also make sure that teams like finance, security, legal advice, people that own different elements of risk, how do you align those supporting functions behind that same mission? Because what I've noticed, especially in government, but also in investigation teams, NGOs, is that they can sometimes be very disconnected. And when they are disconnected, there's a big block sometimes in what can be achieved and the pace at which you can move. But when they're aligned, from an operational perspective, it's a dream. You're suddenly moving twice as fast. They make you look amazing because they've figured out all the logistics for you, etc. So how do you, if you do, how do you try and align those other supporting functions that sometimes feel like a slightly separate element?
Great question, Chris. And I think part of it is what we call single currency. So can you get, and I touched on it in what we were discussing just now, can you get the whole organisation aligned around a shared objective? And then what does that objective mean to different areas of the organisation? So when you cascade it and you contextualise it, what does that really mean? So if I took an example from Formula One, let's say there's a new front wing development that's been tested in the wind tunnel and it gives a few points of extra downforce. The aero engineer gets super excited by that. Brilliant. The race engineer looks at the data and says, okay, that's interesting, but what does that mean to me in a slow, medium, high-speed corner? Yeah. And then the ops person looks at it and says, well, that's really interesting. Looks like we've got something that's an advantage here, but what does that really mean to me? I need to go make this. So how different is it to the one we make today? What have I got in progress and what could I convert to this? Because my challenge is to be able to deliver that really fast. So I'm not waiting for the engineering team to tell me that it's good to go. I'm actually on that already. So that's how you sort of translate it and contextualize it through the whole organisation, because you all have that shared goal. And that's part of the solution. It's not the whole solution, but it's a really good starting point. And if touching on the frustration that we all experience, we know we can do it. We can operate at that pace with that effectiveness and that level of efficiency when we have to. So we did it in COVID. Yeah. We do it in a situation of crisis at war, as you say, in the theatre. Why can't we do 70-odd% of that? We don't need all of it because you burn out, but 70-odd% of that in normal operations. It should all be possible.
So if I just apply a little bit of context to that, when I think about, say, a security advisor that would often be on a project, especially an innovation project where you're bringing in new technology or a new capability, you would usually have a legal advisor, a security advisor, somebody in charge of the budget. And then if it was, say, something more operational, you'd have an admin team. Mm-hmm. And they all have different elements where they can add friction into that process. So the security advisor and the legal advisor, the best way that they can, well, not the best way, but the quickest way that they could minimize risk is by us not doing anything. So it's quite an easy, tempting solution, if I was in their shoes, to just say, well, if I constrain this activity as much as possible, then the risk is low and I've done my job. Now, everybody else can't do theirs, but then if we're measuring these people by the success of how they reduce risk as opposed to by a different success marker, you can totally understand why they apply the friction. Similarly with an admin team, they might want a perfect Excel spreadsheet of all of the finances and everything else lined up. That might be really hard to do if you're deployed in a hostile environment, to get all of your receipts, to remember all of the different expenses, etc. So
sounds like you're talking from experience, Chris.
Not at all. So yeah, exactly. So how do you give them a target that is aligned to the success rather than just aligned to their stovepipe of a good Excel spreadsheet or minimizing risk?
Yeah, so it's a very good point. You get what you measure.
Right.
But you need to be targeting the right thing and then measure it well and feedback through that loop.
Yeah.
I think it comes back to the overarching target. What are we collectively trying to achieve here? What's the objective? And everyone keeps an eye on that. Because if you localize it, then it's all about what you can achieve on your local targets. Well, that may not deliver the overarching target. So for us, lap time, but again, the contribution and the meaning of that to different areas of the racing organisation, it will vary, but it all does contribute to the end result. And so the principle of adding friction, because you'll manage your local targets that may not have been set in alignment with that overarching target, means you add friction, but actually what you should always be striving to do is to remove the friction, because that's the objective that we're going for. And so that's the common currency element to it, and that takes it's quite challenging, and we work on a proof of concept approach. So provide some data points that show that it's actually possible. So we would deliberately constrain an engagement early on to prove that something was possible. It was possible to improve that situation. And then we would look at ways to scale it. And so we have some gamification tools that come from, again, the race background. So we have what we call a StratSim, it's a race strategy tool that when we use that with C-suite and senior management, and we get them to live run a race strategy. It's very interesting to see the reaction around the room. So typically the more senior people are a bit disengaged, but they'll still expect to be making the big decisions at the end. Often not the best decisions, nearly always aren't. Interestingly, those that sit there quietly and bother to absorb the data, understand it and think it through will come up with the best intervention. Yeah. And the whole example and the experience speaks for itself. That actually, back to the point I made earlier, decision at the point of greatest knowledge. Once people understand what the shared target is and you cascade that down, it's contextualized for their engagement in their part of the organisation, they can start to get behind it. But if you give them the right data and you put the decision point with the expert with the best data, you've got to trust they're the best ones to make the decision, the best decision. Yep. So then you empower them to do so and you trust them to do that. And that is it's all part of the same experience, and that's part of the journey through this new way of thinking.
So there's two things that you said there that really struck. I think the first was you get what you measure, which seems to be like a pretty resonating story throughout a lot of what you do. And I'll come on to that in a minute. And then the decision at the point of greatest knowledge. So the way that I in the military would break down any kind of operation would be that there's a very tactical level. So this is, the boots on the ground, smallish teams right at the coalface. You've got the operational where you're managing maybe multiple teams like that. And then you've got the strategic, which is what is our nationwide vision? What's the general direction that we're heading in? So you've got those three stages that we generally think about things in. Do you think that decision at the point of greatest knowledge applies to all of those phases, or are there certain constraints in which you'd say, yes, that's fine in a race for somebody to make a decision tactically, but we wouldn't have, say, engineer X making a decision about the direction of the company or something like that?
So in the race example, that's exactly what happens. It could be a relatively junior engineer, so the expert with the best data, not even at the race circuit. So a lot of that's run remotely these days, has been for many years. So the comms very simply is driver to race engineer, both at the circuit, to the strategist for that driver, who almost invariably will not be at the circuit, will be remote in what's often called mission control. So literally a theatre full of maybe 40 or 50 tech specialists, half the room for one driver, half for the other, strategist at the front orchestrating each of their tech specialists, their half of the room. And the call will come back from the circuit looking for the intervention. So if something happens, I need to know what to do. And I might have a 10-second window before we box. So the car goes into the pit lane. Yeah. This is race engineer to strategist. You've got 10 seconds. I'm going to count you in on one. I need to know your answer. What are we going to do? And that sounds like a really stressful situation. Yeah. the reality is the team are predicting all of the potential scenarios and over-checking all of the time. So there are thousands of simulations running all of the time to look at those different scenarios. So if it happens, we know what the preferred solution is right now. And all we're going to use the 10 seconds for is to over-check. Is there anything else that's coming to us as fresh data that's going to help us make a better decision in that 10-second window? So actually it's a relatively low stress situation, which on the face of it should be very high stress. So that's a really good example of a tactical solution, because you've provided the information to the right people to make the decision, and they will make that call. As a more strategic positioning, you can you still take the same principles. So, for example, we've worked with an oil and gas company that's looking at deploying deep sea drilling rigs, and the numbers are eye-watering. It's circa $100 million to get the rig ready to go, let alone to deploy it. And they've got to decide which contracts to go for, where in the world, for how long. And they said, ultimately, it's like two or three of us sit around the table and sort of try and work it out. And it's a big old bet. Surely there's a better way of doing this. And you can draw the analogy to the race strategy situation, where actually you can provide a decision support capability into them. So if you get the right data, you put it in the right hands, and you bring it up to the surface, you can provide a better capability to make a better intervention. And then ultimately those people might realise, you know what, we don't really need to be making this decision. We've got so good at this now that it can go a level or two down in the organisation. Yeah, okay. And I guess the other aspect we talk about as well, which is linked to this, is the role of the benevolent dictator. So someone's got to make a decision. Yeah. And that will be the dictator, but that dictator is prepared to listen to the experts, listen for long enough, and then make the decision. That's the direction we're taking, and we're all going to get behind it and go. And if you get the right person in that role, 8 or 9 times at least out of 10, they'll get it right. Yeah. And the 1 or 2 times they don't, everyone digs in and everyone learns from the mistake, and they get better next time. Yeah. And you've just got to accept that that's much better than not making any decision at all. Yeah. Because time is money. And that's the experience that we've had. We're back to we want to do more with less and do it faster.
So I think when you say that, what strikes me is that it's not about indecision so much, from my experience of, say, defence as an organisation, but it is about how that decision might be delegated. For example, if you have a legal advisor that says, I recommend against this, again, recommending potentially in a bit of a stovepipe because we've not necessarily measured their level of success appropriately. There are very few commanders that I've come across in my time that would go against that advice. So it almost becomes authority rather than advice. And what you're saying is, no, somebody needs to sit across all of the advisors in the room and then make their own decision on that, and not really give anybody a veto, if that makes sense. So I just wonder if that's
one of the principles. Because you can't react quickly if you're waiting for a decision to go up the chain, and the further you get away from the root data that's going to help you make that decision, the less qualified you probably are to make the decision. So again, push it to the point of greatest knowledge, but respect. You may have to escalate, but you've got to keep that structure as flat as possible. And I know that's a challenge in some of the military structures, but that is one of the core principles of how we operate. That if I go back to Ron Dennis, who's the founder of the modern day McLaren racing team, to his credit, he was pretty good at making the decisions himself on the pit wall. His train set, he made the calls, but he was very experienced, and there's a lot of intuition there. But then even he spotted, early 90s, complexity starting to go exponential. This is beyond my capability, and if we want to keep this competitive edge, it's not me anymore. There's a better way of doing this.
I wonder if that is actually the parallel that I'm noticing about what you're saying around decision-led approach. In intelligence, my background's intelligence, so everything should be decision-led approach. However, I think when intelligence analysts are left to their own device, it becomes more about general situational awareness for the sake of it, because the analyst might not be entirely aware of the effects that the operational elements of the military are trying to achieve. So unless they are directly connected to that, there can be a disconnect between what they go and find out and the insights that they provide versus what the operational elements and the planning elements actually need. Not always, sometimes obviously we get it right. But I think what really strikes me is that it seems almost as if we're still living in a slightly analog version of this decision-led process, this intelligence collection plan. So you talked about sensors. Intelligence assets could be a drone, it could be a special forces operative, it could be any number of different things. But as we enter this much more sort of complex environment with open source information, large data sets, which obviously our company knows really well, I think it does become harder to manage that as a human. So it sounds like what we might be able to learn from you is, how do we digitize an approach that still feels quite analog in defense?
Yeah, that's probably a good analogy to use. And you can probably look at industry as well. So why are we taking this out to other industrial applications? Defence is not unique in this respect, and understanding and respecting program delivery, so empowering the program as opposed to having the strength and the power base in the functional domain. That's a transition that industry, the better end of it, went through probably 30 or 40 years ago, and that's something that is not embraced by all, but it needs to be, and that's again a little bit putting the decision where it needs to be made.
Yeah.
So if you're delivering a product, then someone needs to own that delivery from start to finish, and it's uncomfortable for some. It's full empowerment, but also full accountability. So using the old phrase, one throat to choke. You are on point for this. Yeah. So you do want your best people in those roles, but it's not a blame culture either. It's like, if it goes wrong, we need to learn from it, and that's something that's very much come to the fore in Formula One in more recent years. Yeah. It's really harsh competition, and you're tested in front of the whole world. Yeah. But if it goes wrong, okay, there is no blame. It went wrong. We need to learn from this, and then feed that back in to get better next time.
I think there are some parallels there. So we have mission command, where we express intent, but we leave the how to the people that were delegated that task to. I think what's interesting in what you were saying earlier about the there's 10 seconds to make a decision, but actually that decision has been pre-sequenced, and there's maybe a couple of playbooks that are almost off the shelf at that point because you prepared so well. So rather than just relying on, say, an analyst or an engineer, you're also relying, it sounds like you're relying on a system, or you're at least relying on institutional preparedness. I think the closest we get to that maybe in the military is doctrine. So if we ask, say, a group of soldiers to carry out a task, they're not making it up on the spot. They're using their training, their doctrine to apply to that task. But I wonder how much of this is trust of the person versus putting in place a good system that you therefore feel more comfortable with delegating the decision to?
It's both, for sure, because you can't step to a new way of operating without putting the strong system in and respecting the cultural change as well. It's very difficult for people to let go of some of that sense of responsibility for making a decision, and understanding. I can remember being in that position as well, owning a big chunk of the engineering activity, and then realising, actually, I'm off my domain. I shouldn't really be making these decisions, but no one else is, so I've just stepped in. But if we were to organise ourselves properly, I definitely wouldn't be doing that. And so there is a sort of a cultural transition to go through. So that is certainly part of it, and it's not an overnight. You can't flick the switch, but that's why we go back to, can we do a controlled proof of concept to give a demonstration of the art of the possible? And then people can start to see that and experience it. And if you work with the partner organisation, the client, you're actually taking some element of that forward with you. So they learn by doing, and I'm a great believer in that. That's the best way to learn. And then you've got some people inside that organisation who have just learned how to do things differently and are inspired by it, and they can start to take that forward from within the organisation. So that's a key part to it. But it's not overnight, but there's some really simple lessons, and there's some really good data points that we can create by running those proof of concepts through the organisation.
So I think one last question from me before I steal all your time. I'll give you back to Terry in a second. I think, so if you were, for any leader that's listening to this, whether that be a leader in the military, or whether that be a leader of, say, an investigation team or people, aid workers or anyone in complex environments, what would your advice be to them about, some of these topics that we've been talking about? How could they maybe feel the confidence that they can delegate decisions? What should they focus on first in terms of the systems, the structures, the cultures? What would be your top advice for a leader that's thinking, right, how do I apply this?
Good question. So I think it starts at the top with what's our shared objective. So what's that common currency that we should all be orientating ourselves around? Once you've got that clear, okay, so what do we need to understand to enable us to do that, to deliver that target, be more effective at what we're doing? And that comes down to, have we got the right data around us? And that's a bit of the sort of foundational element. And then once you've got the data, can I get it into the right hands at the right time? And they go, okay, so it is now. So are they the people to make the decision? They probably are. Let's just test that out. So it's a step-by-step process, and you do it in a controlled way initially. Again, it's not flick the switch and you're there tomorrow. You start that and you grow it from within the organisation, and then you've got people on board with this slightly different way of doing things. And then once you've got that in place, you can start to look at how do we get this to the wider audience. And again, we use gamification tools, so that there's other ways of doing it. And then ultimately people, the organisations want to get to this decision intelligence capability, which is the top level of our what we call industrial racecraft. So how do you support the human who's on point for making an important decision in a limited amount of time with way too much information coming at them? And when you analyse that, an experienced person in that space might be able to deal with 2 or 3 different options when under pressure. If you can boil that down to one and be really clear, that is the optimised intervention, that's great. And the decision support tool should enable that to happen. So that's where you bring that capability through the organisation. You've built the foundation of understanding what the common target is, what data you need. Have you got the right data with the right person at the right time? The organisation gets it because you've been through that cultural transformation. And ultimately you qualify yourselves to work in that decision intelligence level, where you can make better decisions faster, which then translates to better product faster to market, etc.
So that resonates with one of the principles that I talk about in leadership is like ruthless triage. And it sounds like that's exactly what you're doing here. But it also sounds like there are some infrastructure things that you have in place that enable that. You talk about a terabyte of data going from the car to the side of the track to God knows wherever else, so that thousands of analysts can look at it. Sometimes I struggle to get all the way through a Teams conversation without losing connectivity. So, there's that part of it. And then I think about data visualization. So, looking at huge amounts of data in a way that can be meaningful to an analyst in the moment at speed. And until you get some of these components correct, until you've got great communication across all of your stakeholders, a way of visualizing that data that you're collecting, it sounds like that ruthless triage is going to be quite challenging.
But you start with the basics, and it's relatively simple. So we have another phrase, understood at a glance. So make it simple. Don't make it complicated. Anyone can make it complicated. The skill is to just pull out the really important stuff and make it really clear. So if you're trying to make a decision under that pressure in a race environment, you'll note if you went round those 40 or 50 different tech specialists in a mission control, everyone's screen would be configured differently to suit the individual. So and the software that is developed for that purpose is deliberately configured like that, so that it's very adaptable. And so every individual will want to see things in a different way because it suits them. And a great example is, it goes back to a race example where when you turn up at a circuit, you expect to get a trace of the circuit, and you would then start to plot your data on that form of the circuit. At one race many years ago now, McLaren turned up and there was, everyone turned up and there was no data available. It was a new circuit. So, what do we do? And it was one of the guys who works for us now actually was at McLaren, and they said, well, we don't really need the circuit, we just turn it into a circle. because I don't need to see the form of the circuit. I just need to see where all the cars are relative to each other.
Right.
So it's a real simplification of something that was overly complex. It was the circumstances that around that led to them finding that piece of innovation. But that's a really good principle to refer to. So make it as simple as you possibly can.
Right.
And that understood at a glance is really, really key.
Yeah, I really like that. I can totally see the application of that in the military. Anyway, sorry.
I guess these were fascinating questions, and I've got so many thoughts buzzing around in my head now from just what you were talking about there, Chris and Mark. And I just wanted to sort of maybe lead it back to one key element that I think we've not yet really touched on, which is the speed of innovation. And so within Formula One, you're having to innovate so fast. And I think this is something we've seen, obviously, in the last few years with the war in Ukraine. The speed of innovation has accelerated so rapidly, and of technical innovation, but also of doctrine. Mm-hmm. How do you fight a modern war with the kind of technologies that are available? And I know some people might look at Formula One and they might say, well, it's a very closed game. It's a game. So it's got rules, it's got certain parameters that you can plan for, and it's got a schedule that's planned out so far in advance. But I think that's almost missing the point. I think hopefully you'd agree, in the sense that so many of those caps that are put in place, like the spending cap, etc., and the other restrictions, they are mirrored in real life. Like if for example, if you had a Formula One team that had no restrictions on how to build a car, no restriction on budget, you would probably build a very different car to maybe some of the ones that are out there. But that's not real life. That's not how things work outside of a sport, let's say. And it's not how things work in defence. There are restrictions, and we all operate under, spending caps and budgets and whatnot. So, all of these things, I think there is a natural allegory between Formula One and defence there. But maybe you can talk about that speed of innovation question. How do you innovate at speed when you've got maybe a couple of weeks between races, or, and you're in that competitive environment where there's these other teams who are all trying to do the same things to get that competitive advantage?
Yeah, it's a very, very insightful question, actually. Yes, just recognising there is a regulatory framework and there's a schedule, etc. But there's also an opportunity for competitive advantage to be found within that set of restrictions, and that's what people in racing are trained to find. So how can we find a bit more beyond what other people might find? And
that's maybe a technical advantage, but is there also a decision advantage? When you're talking about intelligent decision making and using data in a smarter way maybe than some of the other teams, is that also an element of this?
Absolutely. Yeah. And I mentioned the cost cap, and actually teams have got better at what they're doing because of the cost cap, so they want to get more out of a limited amount of resource. And so that it's all about down selecting the best innovation as quickly as possible, because you can't afford to put too many through the system because you're just wasting resource because you're not going to take them all through. So decide early, fail fast. And then it's all about how quickly can I get that good idea through to a track advantage. And you set the whole organisation up to operate like that. And so a part changes on a Formula One car every 17 minutes, 24/7, 365 days of the year.
When you say changes, in what way?
So it's updated. A part completely changes or is modified. So there's always performance to find. And if you're not working at that pace of development, you're too slow. So if you started the season, the first race of the season, and you were on pole position, so you're the fastest time, and you did nothing to your car over the course of the average season, by the last race of the season, you will be lapped by every car on the grid.
Wow.
And that's the difference. So that's the cost of not working at that pace. And so it's about focusing down on the most important stuff as quickly as possible. And we have a phrase here that we use, we call it the bad car. So don't prevaricate and wonder what it could be and finally polish and fettle. Just get something out there and test it. We do a lot in the digital space, and that's absolutely the most effective and efficient way of refining, developing and optimizing a complex product. But you always have to check that against reality. So what data can I get from the real world to check back that I'm pointing in the right direction? So the bad car analogy is, we'll get something out there, it's not right, but you're going to get some data from it, and you'll learn from that data, and you can feed it back into the process. And don't be scared of doing that. And if you look at perhaps some of what's being learned in Ukraine, where they're having to innovate and they don't have a lot of resources at their disposal, but they're coming up with solutions. It's kind of the home garage mentality of, well, what could I do? And it's almost what's the $100 solution to the $1,000 problem, because you can't be using a £250,000 solution to take down a drone, for example, that might cost £1,000. You've got to come up with a better solution, and that's where that's the challenge. And let's come back to the fact that the UK is actually really, really good in terms of sovereign capability. We have a lot of this in the UK. We are world leaders in Formula One engineering, and we've just understood some of what that means, and we've demonstrated how we could apply that in the COVID crisis. So it stands as the point of reference. And there was only one nation, every nation globally under COVID tried to build ventilators. Only the UK was successful. And I would put that down to the leadership from the Formula One contingent.
Purple sector,
exactly.
Yeah.
Taking mainstream industry with us on that journey. And mainstream industry was blown away by what was possible in that time frame. So we have that capability. We need to work out how to best harness that and take it to some form of scale to be effective at the national level. And I think we have a fantastic opportunity to do exactly that. We've just got to enable it to happen. We put too many blockers in to stop that. And to Chris's point, when we get into the crisis, we do manage to do it. But again, why can't we be at 70% of that all the time?
If UK defence was racing in Formula One and we were looking at our adversaries, how much do you think we'd be in danger of being left behind on the circuit or being out-innovated over the course of a season?
Interesting take on the situation. So I think it's more important, perhaps more important to think about where your adversaries are and where they could be. So what are they doing that's different to what we do? So that rate of innovation and rate of learning. So we've talked a little bit about the Ukraine experience and the fact that they're having to innovate with very little resource available to them, and that's driving a certain level of learning, and that we need to recognise you can learn from that environment significantly. So where could others be, our adversaries, relative to us? And then that sets our challenge in front of us. And I think you'll end up in the same conclusion that we have to change the way we do things.
Thinking about your experience from the COVID period and the ventilator challenge and the success that you had there, how much do you think that relates to what the government is now talking about when we think about defence and innovation, where they talk about this whole of society approach and trying to bring people from different sectors and different parts of our society, not just defence, along with us? Is there something that can be applied from what you did then to this kind of current environment?
Absolutely. It still stands as the benchmark project within government and within industry. So that there's lots to learn from it, and it's very encouraging that those conversations are ongoing. I would say that, again, back to be realistic about what we can achieve, and let's generate our own proof points, and let's deliberately constrain the boundary conditions so that we can run a project and as a demonstrator, and maybe then a series of projects. Start small, but think big and scale as fast as you can.
Is that partly down to the government following through on some of the things that we've heard about encouraging more SMEs to get involved, especially when they're bringing innovative new technology to the fore? You're seeing challenges, I'm sure, there, as are lots of other SMEs in this sector. Maybe you can just touch a little bit on that and what you'd like to see actually happen in terms of trying to get some of that innovation through quicker.
Yeah, it's really interesting because from an operational perspective, there's clearly multiple demand signals for what we're putting forward. The challenge comes in actually acquiring some of that through a commercial process and associated processes. And so whilst there's a clear desire, I think there's still a lot of inertia in the system. And I think that the biggest step we could make is to break some of that down. Like I say, maybe make it much simpler to do smaller engagements faster to prove that there is something here. Definitely there's opportunity. Definitely we have to think about how we would engage with SMEs in practice, because again, we can speak about a desire, but there has to be a practical solution.
Yeah, definitely. I mean, I think everything you've said so far is all about practical solutions and delivering something that has an effect and isn't just about designing things that are in theory a great idea but don't ever see the light of day. And so so
maybe go back to the ventilators. One of the key enablers, looking back at it, was the fact that none of the organisations involved were prepared to move until there was a cash injection. So literally I came up with a spreadsheet, cooked it up over one evening, over one night probably at that stage, and presented it, and we went through it, and it was deemed to be rather simplistic. And I said, well, it's only as complicated as it needs to be. If you look at the number in the bottom right, that's what we need, and that's the timeline. And the team within the Cabinet Office bought into that, and I said, look, the money has to cascade. It's got to go to the ventilator manufacturer, who that was the company we were supporting, because they were the certified entity. And we said, okay, but they've only got 1.5 people in their finance team at the moment. This is going to be too much for them, so we'll bring in a third party, and they'll support them, and they'll also be the audit partner as well. And you'll be able to drive a bus back through this afterwards. It'll be complete transparency. And that gave them the confidence to allow that to happen. And we were then in a position where we made our own decisions and moved at pace. And we would, we'd report back, and we would report progress against spend. And when we were getting close to the threshold, we would then call down the next tranche of money. And that really enabled us to move. And if I compare that to a follow-on experience where we were asked to come in and help with COVID testing on the automation side, we weren't able to land that configuration as an operating model. And I'd have to say we probably could have done what we eventually did in that space in 25% of the total time spent. And again, time is money. So there was a lot of learning from that. And someone within government's got to take the brave pill. But the truth is, you've got to accept that there'll be a few mistakes along the way, but making progress is much more important. So again, 8 or 9 times out of 10, you get it right, and you learn for the 1 or 2 times you don't, and you keep moving forward. That's better than indecision and burning money going nowhere.
This has been fascinating. I've got one last question that it would be remiss of me not to ask, because I was telling some of our colleagues before we came down here to record this episode about the topic, and they all got very excited. We've got a lot of F1 fans in the company, and I'd just love to get your thoughts on this season, because it's a new era. We've got new regulations that are governing how the cars are powered, for instance, and it seems to be changing the way that racing happens. So in a similar way to what we mentioned there, in terms of, a very different environment, but the technological change we see in defence driving a different way of having to operate. I guess drivers are having to adapt to a new world and a new type of racing, the teams as well. So, we're a short way into the season, but it'd be great just to get your thoughts about that change and all the changes we're seeing and what it might mean for the sport this season. Are you excited about it, I suppose, is the key thing?
I'm always excited. The most exciting race of the season is the first one, to see where everyone sits.
Yeah.
In fact, I used to go away with my team at Mercedes, and if we weren't at the race, we'd be in a place all together watching the race, normally in the early hours, because it was the other side of the world. And you're on the edge of your seat, because that is the most exciting time. Where are we relative to everyone else? So complexity's gone up another notch or two, particularly on the powertrain side. And if you talk to the drivers, I think a lot of them will say, by the time you get to Formula One, you can drive. And that has to be like a second nature capability, that and your drive and race. But the real noticeable transition or step when you go to Formula One is the mental load. There's a lot more you need to get covered in your mind before the race, definitely during the race with a lot of the different strategies, different controls, and this is before we got into this year. So I think this has gone up another several notches, and it's really quite complex to work out what you need to do when. What we've seen so far is some good racing. That's positive. What we've got to be careful not to do is to have a solution that ultimately looks to be a little bit contrived.
Yeah.
So I think what will happen is that we will evolve the current position, and we'll learn what works well and what is not working quite so well, and it'll be learning for the future. But the technology itself is relevant because it needs to be relevant to a direction of travel for road cars. Yes, sustainable fuel is being used. Yes, it's an aggressively downsized engine, so it's a much smaller engine with a lot of specific power, so high power density. And there's an electric system that is about half of the total power output. Yep. The downside of an electric system is that the energy storage system, the battery, is nowhere near as energy dense as the fuel that goes through the engine. So you're spending more weight in doing that. And that is a challenge to the rest of us as well. So what's the solution going to be going forward? If you bring that back into the real world, then actually an electric car is great when you've got high population density and you've got relatively short journeys, low average power consumption. It works really, really well, and it's clean at the point of use. And I'm sure we'll look back in 50, 100 years' time and go, really? We burnt fossil fuel at every single point of use? That's mad. And we strapped all this technology around the product to try and make it okay, but it never really was okay, was it? But then when you come out of that environment, you drive up the motorway, for example, with a more heavily laden vehicle going at a higher average speed, burning a higher average level of power, then the battery becomes challenging because you don't have that energy density. And the extreme case is flying across the Atlantic. You won't fly in a jumbo jet that's electrically powered because it'd just be too heavy. So this learning that we're getting in Formula One is ever so relevant for the direction of travel in mainstream going forward.
What would have been the challenge, though, at the start of this season for the teams in terms of what we talked about earlier, when we talked about digital twins and simulation and using the data? How hard would it have been for them to simulate what would have happened in that first race and to make their decisions based on that?
Easier for some teams than others. Because if you look at incumbent powertrain suppliers with experience behind them, had an advantage because you would have started the development of these sort of systems probably 5 years ago. Wow. And they would have been learning a lot from hardware in the loop testing. So they've had a lot of hardware subsystems testing, feeding data back to the models or the digital twins, looking at the integration of the full system and how you optimize that. For those teams that were maybe fresh to Formula One, and this year there's been a couple, a much bigger challenge for them, and for customer teams as well, also a big challenge because they wouldn't have had the experience of living with the hardware, the data, the modelling for as long as the works teams. So to varying degrees, and I think you can see that in some of the results, that's coming through. But again, we'll develop forward and everyone will start to learn. So if you look back a year, we'd had stable regulations and everyone had learned a lot. So it was in the diminishing returns part of the curve. So it was a very level playing field. We've just thrown the dice again and it's a bit mixed up. But everyone, again, it's back to the rate of development. So how quickly can you learn? And the gap will start to close.
There's obviously a lot of innovation this season. And
for sure. Yeah, for sure. Yeah, there's a lot of pressure for that. Yeah.
Maybe more racing and a bit less Mario Kart.
Yes, I think so. Yeah, I think that's coming. Yeah.
Cool. Well, it's been great. Thank you so much for your time. I've learned a huge amount, and I think I'm taking away a lot of food for thought from this. And just in terms of where the gaps are in defence, my mind is buzzing right now in terms of some of the ideas that we've discussed and where you can bring some of these capabilities to the fore and hopefully make things better for all of us. And so, thanks so much for your time. It's been great.
Thank you. Thank you.
Yeah, it's been fascinating, and I wish you were around when I was bringing innovation into defence. I think we'd have had some very interesting chats.
Yeah, it's an absolute pleasure talking to you today, both of you. and hopefully we can work together and make some changes.
Sounds good.
Okay, Terry, so in the spirit of the analysts in F1, I want you to give your final thoughts in 10 seconds.
I mean, it was amazing. I think we've learned a lot. I think the prime takeaway I've got is connection. How do we connect defence together better so that the whole operation works more seamlessly and is aligned behind the mission? And that, for me, is what industrial racecraft should bring into defence.
Yeah, absolutely. Nice. Well done. I think what I got from that was you get what you measure. I think that was a very key lesson. Be clear what your objective is and put all your stuff behind that objective. I thought that was really cool. Keep it as simple as it needs to be. I think that's such a great message, especially for people that are overwhelmed with difficult contexts and a lot of information. And I think that this conversation will give leaders a bit of confidence that they can see this working elsewhere and it's worth making those changes. I really like the idea actually about the bad car concept, because whilst you can look at that as a threat, if you're in pole position and you don't innovate, you can end up at the back. It also means you can be at the back and you can lap the pole position if you do innovate. So I think that gives us both impetus and hope at the same time. So those are my key takeaways.
Yeah, absolutely. I think it's that about that, making decision making more intelligent. And we are familiar with defence sort of doctrine and OODA loops and thinking about OODA loops and
intelligence collection plans.
All of this process around intelligence, and that's all geared towards supporting decision making. But I don't think we ever really spend enough time analysing and assessing how do we do this and how do we make it more efficient and more effective, given all of the data that's out there. We're not pulling that data together effectively enough across defence. Yeah. To be able to use it in the way that Mark described, where you get insights at a glance, and somebody can support a decision in 10 seconds, and they can feed that through. So it's all of those elements coming together, as well as you think about designing sensors that actually give you what you need, rather than just collecting whatever data you can get hold of.
Noise.
Yeah, collecting noise, exactly. Yeah. There's a lot of noise collection that goes on, and there's a lot of then head scratching around what do we do with all this, because we don't know how to use it effectively. And I mean, hopefully we're not giving away too much about how defence currently operates, but I think you and I have both seen a lot of the things that frustrate us from within and outside supporting, not just the UK. And this is across the board. I think it's important to say this is not just the UK.
It's across the board.
This is in other countries as well. Yeah. We see the same issues where the same kind of culture ultimately sort of stifles some of the innovation that we would want to see in peacetime, which is exactly what we've talked about here with Mark.
Yeah, I'd really like to see Purple Sector do an audit on the way that we do intelligence collection, how we measure. I think that would be really interesting because I think we're trying to do it. Yeah, just having some guidance on how to do that better, I think they'd give some really good insights.
And even if it was in a sort of simulated environment where we could say, look, this is how it normally works, and describe it and walk through it, and it would be interesting to see what the output would be, especially when you talk about digital twins and simulations, and you could run it against adversaries in a specific scenario. But that would be insightful in and of itself.
Yeah, for sure. Yeah.
Lots to learn, lots to apply.
Yeah, agreed.
Sensing the Signal is brought to you by Atreides, the behavioural analytics company. If you enjoyed this conversation, you can find out more about what we do at atreides.io.